Okay friends, welcome to part 1 of our chapter 6 video presentation. In this presentation we will talk about managerial support systems. Now another term for this concept is management information systems, or MIS. In fact, I would say MIS is a much more common term than managerial support systems. Now if you remember, last time we talked about the so-called enterprise systems. That's what chapter 5 is about. So what's the difference between enterprise systems and managerial support systems? Well, on the conceptual or theoretical level, the difference is that enterprise systems, they aim to support the entire enterprise or the entire organization. In other words, enterprise systems such as ERP systems, they aim to automate, to streamline all processes within an organization. Now, managerial support systems, on the other hand, they're typically exclusively focused on the specific decision or information needs of managers or group of managers. So not every employee within an organization, but managers. But on the technical level, managerial support systems, they're often a subset of enterprise systems. In other words, a lot of enterprise systems nowadays, they have capabilities for decision support, managerial support, and executive support. So that's the technical and conceptual difference between enterprise systems and managerial support systems, or MIS. As a part of our Chapter 6 discussion, we will talk about the following managerial support systems. We'll talk about decision support systems, or DSS. We'll talk about systems that are used for data mining and data mining in general. We'll talk about group support systems, or GSS. Then we will talk about geographic information systems, executive information systems, business intelligence systems, knowledge management systems, expert systems, neural networks, which are not really separate systems. Neural networks is an algorithm that is typically a part of expert systems or data mining systems or decision support systems. And then we'll briefly talk about virtual reality systems that are used in various organizations. So that's the roadmap for Chapter 6 video presentation. Okay, let's talk about decision support systems first, or DSS. That's a very popular acronym. Basically, decision support systems, they provide interactive or computerized decision support for both structured or unstructured problems. Structured problems are the ones that are complete, meaning like all the variables can be specified, and then based on those variables, a particular parameter can be calculated so a decision can be made. Poorly structured are typically problems that involve a lot of unknowns, some degree of serendipity. Nowadays, decision support systems, they provide support to both. They can provide support to both types of decision making. Data for decision support systems often comes from transaction processing systems or data warehouses. So let's say a sales system can accumulate sales data, and that sales data will be used by decision support systems to project or predict sales for next quarter or next year. Alternatively, this data can be retrieved from a data warehouse. Now, in addition to data, decision support systems, they incorporate models. Models means like some kind of conceptual idea, and typically it's some kind of statistical analysis model or mathematical model that takes data as an input and provides output that is either a decision or some kind of information that is very helpful in making a decision. Now, decision support systems was a very hot topic, I would say, starting 1980s and through 1990s. In fact, the field of information systems, that's the field where I'm coming from largely. At that time, the field of information systems was largely defined in terms of decision sciences and in terms of decision support systems. So, for example, even the department I graduated from the University of Houston was named Department of Decision Sciences. So DSS was a hot topic, and I would say like starting late 90s, the interest started to cool off. And that seems to be the a natural path for any kind of technology, for any kind of managerial fashion, where there's a lot of hype and then the interest kind of cools off. So I think starting late 99's interest in decision support systems started to cool off, because managers and society, public in general, they began realizing that some of the most important decisions in an organization, they simply cannot, they're poorly structured and they simply cannot be made with the help of decision support systems. So the interest vanished. Now I would say as computers are becoming more powerful and as processing power is cheaper and more accessible to everybody, there is a resurgence in the interest in decision support systems. So people are talking about decision support systems again. And of course the hype cycle is over, so decision support systems, they don't have to prove anything yet. There are a lot of useful decision support systems out there that demonstrate clear value to organizations, and that's why I think the interest in decision support systems, or DSS, is coming back again. Now, just to repeat that, decision support systems typically have the following components. First of all, there's a data component, or component related to data management. So this component helps a user retrieve data from both external and internal sources, process the data, and store it in a format that can be subsequently used by a decision support system. Then there is a model management support. Basically, data is useless unless you apply some kind of analytical tool or analytical model, let's say regression model, to the data. So typically, decision support systems, they have a repository of various analytical models that can be applied to data. And then there is dialogue management, meaning that IT component that helps a user to use models in relation to the data that is available to the decision support system. And sometimes decision support systems are integrated with other systems, let's say an overall enterprise resource planning system. So that's a very basic architecture of a decision support system. An example of a decision support system that comes to my mind is SPSS, or Statistical Package for Social Sciences. That's what SPSS stands for. So basically, they have basic data management capabilities where you can enter data in the form of an Excel-like sheet, and then they're very heavy on the model side because SPSS will have a lot of statistical data mining models, and then there is a user dialogue. One thing that made SPSS quite famous and popular was that they created the so-called point-and-click interface. Just similar. The idea similar to this was implemented at Microsoft Office, any kind of visual interface applications. So it made statistics relatively easy, and that's why it became popular among broad masses of researchers and scientists. But SPSS also has a command line interface, but it looks like most people are using that point and click visual interface for doing data management and analysis of data using various models embedded in SPSS. And SPSS can be integrated with some enterprise applications as well. Now, a distinction should be made between specific DSS, specific decision support systems, meaning actual DSS applications built for a specific purpose, to directly assist with a particular decision-making scenario, and a DSS platform or DSS generator, which is a software package, for example, spreadsheet, used to build a specific DSS model quickly and easily. An example of a decision support system generator would be Excel. I mean, Excel is a very widely used software package for building various decision support models on the top of it. In fact, one of my first exposures to decision support systems was through Excel. At that time, I was an undergraduate student and I took a course in finance. And I remember our finance professor, he would bring, our finance professor, he was like a retired, investment banker, I guess. And he would bring to class his old Excel sheet models for some of the company evaluations that he did. So basically his job was to evaluate companies, evaluate financial health of companies and project their future financial performance so that, investors can make a, informed appraisal. And that's when he showed those Excel models to us. And then, I think I got to the heart of this issue because I was very puzzled because of, those Excel models that he built, they would provide like a, dollar or cent precision about, revenues 5 or 10 years from now. And I found it puzzling. I was like, how do you know that revenues will be, $1,900,038.65? I mean, can you really predict future revenues with that kind of precision? And that's when he said, well, that's the thing. Decision support systems, those Excel models, they're not 100% precise. But at least, by building those models, you can, look at different scenarios that will help you decide, what is possible and what are some of the likely scenarios, giving the information that you have. So yeah, decision support systems, we wish they could be 100% right when it comes to predicting future and making sure the decision correct, but they're not. Typically, decision support systems, they're very useful in very structured, meaning routine, highly formalized decision-making scenarios. Let's say like finding a break-even point, or estimating like some kind of average employee performance, and then based on that deciding how much employees should be compensated. So routine problems can be solved with decision support systems. But the most fundamental questions, such as how do we produce a great software product, or how do we make sure our customers are satisfied, sometimes can hardly be answered with decision support systems. Okay, data mining. Now, data mining is once again gaining momentum nowadays because maybe you have heard about the so-called big data movement. So basically, big data movement says that organizations across the globe, they're sitting on a wealth of useful data and information. Some experts compare the data that organizations have to unexplored deposits of oil. So they're saying a lot of organizations nowadays, because everything is digital, everything is performed with the help of computers nowadays, they generated so much useful data that can be used for improving operations and competitive advantage, that will be like the focus of competition for the next decades. In other words, getting data out and trying to mine it. And to mine data means to go through all those huge data sets that a particular organization may have, to discover information, meaning some kind of useful knowledge from all those vast volumes of data. Now, in order to do that, a number of algorithms or decision techniques are applied to data. For example, decision trees, regression, association rules, clustering, rule induction, statistical extraction of if-then rules, nearest neighbor, which is related to clustering, genetic algorithms, which is an algorithm for finding solutions based on kind of random seed. So there are a lot of algorithms out there for data mining. And again, data mining is gaining momentum nowadays. It's been around for a while, it's gaining momentum, and it seems to be like one of the hottest trends in computing nowadays. So what can be done with data mining? For example, you can discover knowledge that will help you in cross-selling. For example, you will discover that people who buy milk, or people who buy bread, they also buy milk, right? So if you see somebody ordering bread, you can also suggest to that person to buy milk, right? So that's cross-selling. Predicting customer churn, for example, you can look at your customer records and discover that before a particular customer, let's say, cancels his or her subscription, there are a number of steps or parameters that are visible. For example, he submits, on average, a customer who decides to cancel subscription, before doing that, he or she submits 3 complaints and, let's say, calls the call center twice. So if somebody has submitted 2 complaints already, maybe you can be more proactive in terms of approaching that customer, solving his or her problem so that he doesn't or she doesn't cancel the subscription, right? Direct marketing, again, you can data mine your customer records to see which customers are typically interested in which products or what kind of price range. Fraud detection, you can identify unusual patterns and then correlate unusual behaviors of a customer, let's say online, and then correlate that behavior with some kind of fraudulent acts or criminal acts. For example, you can discover that a person who tried to log in unsuccessfully 10 times is a potential intruder because maybe he's trying to guess password. So there are all kinds of interesting applications to data mining. And again, as computing and data storage is becoming cheaper and more accessible to everybody, this movement is gaining more and more momentum. Now, there are a lot of examples of data mining being used for improving operations and competitive advantage, but one example that is probably the most powerful and widely used is Amazon recommendation engine. Now, Amazon as a company, they have been one of the pioneers in using data mining for improving their sales. And I can attest to that because I've had my Amazon account for many years now. And sometimes I'm amazed how good Amazon is at predicting what kind of books I'm interested in. Usually like when I get emails with marketing information, I delete them, I don't read them. I treat it as spam, and rarely, actually, I cannot even recall seeing anything interesting or useful for me in those commercial spam emails that I get from various websites. There's one exception, and that's Amazon, because I always pay attention to what Amazon is sending to me, because somehow, sometimes they know what I'm looking for, even before I can actually formulate what exactly I'm looking for. So the kind of precision for cross-selling that they have is just amazing, and that's entirely due to data mining. They're using very huge data samples, huge data sets, and very sophisticated mathematical and statistical model to analyze their customer behavior, and based on that deduct all those correlations, like if you bought this, then you're likely to buy this, and they're trying to gear their marketing efforts towards that. Our data mining software nowadays, because as I said, data mining is a growing trend, growing field in computing. More and more companies are offering data mining packages. Probably one of the most well-known ones is the Enterprise Miner package by SAS. It's a very powerful package, very expensive as well. IBM has a lot of, not a lot, but at least a few data mining tools. One of them is SPSS data mining module, because IBM bought SPSS, that statistical package for social sciences, a few years ago. Now there are also some open source tools, and I added the list here. For example, Weka, or Weka, I'm not sure how to pronounce it. Now that's a package that was built by one of the universities in New Zealand. It's Java based, it has a visual interface, it's free. Then R language and RStudio, which is the visual shell visual environment for the R language, is also increasingly having all those add-ons and modules. Different modules are increasingly being added that can help you in data mining. Personally, I use RStudio for my data mining tasks. And basically, I'm enrolled in an online diploma program in data mining. So and I'm actually about to graduate. I just have one course or half a course left. I believe it's a 5 or 6 course sequence. So I have last course left. So I'm doing my capstone project, and I do everything in R. Now there are some problems with R. I mean, R is not good at handling huge data sets, and the data sets that are giving us are huge. They're like gigabytes of customer reviews. So sometimes, a few times I had to wait for a few hours for RStudio to complete like a particular data mining task. So I kind of quit doing that because I don't have time to wait for 4 or 5 hours before I see output, and my computer is not powerful enough. So what I do, I just take subsets from those huge data sets. I just randomly draw samples, and then I do my data mining on those randomly drawn samples. But anyways, things are changing, and I know that there are some big data modules being currently available for RStudio. Those modules, they will solve this problem of R not really being appropriate with large data sets, unlike such applications as SAS Enterprise Miner. But of course, it's also it also depends on the kind of hardware infrastructure that you have. One thing that is also worth mentioning in connection with data mining is OLAP, Online Analytical Processing, probably one of the oldest and one of the most widely used forms of human-driven analysis or data mining. Basically, it's a way of zooming in and zooming out on your data. So OLAP allows a user to rapidly categorize data and then drill on specific categories. For example, using an OLAP application, you can ask database to generate reports, let's say for different years, 2004, 2005, 2006. Now once you do that, you may drill even further, and you can say, okay, for 2004, I want to see data for, not sure how it's spread out, for outdoor protection, right? So you want to pull this cube, right? So once you look at this cube, you may want to drill even further by saying, I want data for 2004 for products related to outdoor protection. Moreover, I want to make sure that only for sports store retail, this data is provided only from department stores or sports store retail. So you're kind of zooming in on a more specific cube, right? So this allows to kind of allows for very structured, logical, and at the same time very intuitive and useful analysis for all kinds of data, this kind of OLAP approach. And there are analytical tools, there are also visualization tools that help you visualize those, not only recognize but also visualize those cubes for subsequent analysis. Okay, one system that is typically a part of that DSS or decision support system family are the so-called group support systems, or GSS. Just like it was the case with DSS, it was a very hot topic, back in 1980s, 1990s. Everybody was doing research on group support systems. But eventually those group support systems, they kind of lost popularity. I mean, there are some examples, they're still being used in certain organizations, but again, they don't have as much hype, as they used to. So, as you can tell from the name, group support systems, they basically automate or streamline or assist groups in making decisions. So a group support system may be arranged something like that. You have a local network, and then you have all those workstations, and there is a human sitting behind every workstation, and every workstation is equipped with some kind of visual interface of a software that asks people to provide their input about a particular situation that is displayed on a public screen, and then they enter their analysis or their suggestions, and then based on group feedback, the system will create like a solution. Okay. I think the problem with GSS is that it's based on one fundamental assumption that doesn't seem to be necessarily related to computing. That assumption is that the wisdom of the crowd is somehow useful, right? So maybe it's useful on some kind of ideological point of view. In other words, from the perspective of inclusion and democracy, it's important that everybody provides feedback. But research shows that group decision making does not necessarily lead to better decisions. In fact, groupthink can be, a negative phenomenon. In other words, it may be actually harmful to rely on what groups of people think in certain situations. So I think that's why GSS or group support systems lost momentum, because a lot of practitioners, a lot of research studies, they just couldn't demonstrate ROI. They couldn't demonstrate much return from those kind of applications. Okay, and then you have geographical information systems, or GIS. Basically, those systems are based on some kind of geographical or relational data in space. Some of the early GIS users involved, various government organizations such as public administration, NASA, military, law enforcement, forestry, natural resource management, let's say oil exploration, because all of those applications, rely on geographical information. In other words, mapping, and geographical information is very useful for those kind of applications. So when you combine geographical information, so map, with additional data, that forms a very useful system. But nowadays, GIS are often used in business, for example, for determining site location for, let's say, a restaurant or a distribution center, for doing market analysis based on geographical location, for logistics, routing, dispatching, for environmental engineering, for geographical pattern analysis. For example, Disney analyzes how visitors to Disneyland, how they interact with their parks, where they go, where they stand, where they spend most time, most money. So all this information that is related to location within the park is fed back to their system so that they can optimize, experience of visitors to Disneyland, and by doing that also maximize their revenues and profits. A lot of nowadays GIS are often driven by mobility. For example, if you use your cell phone, if it's an advanced handset like iPhone, it can be equipped with GPS. But even if it's not, your location can still be deducted by roughly approximating which mobile tower you're connecting to. So sometimes, mobile networks, mobile phones, they use on the top of GIS information systems to identify location of people. Geographical information systems, they vary in terms of how they represent data. Sometimes they represent data in a kind of logical format or raster-based format. They basically divide space into small uniform cells in a grid, as opposed to providing like real life, real world characterization of geographical space. So basically, it's like a grid, some kind of grid that is used to to identify a location, and each cell in that grid schematically represents a particular location. And then you have vector-based GIS that associate features in the landscape with a point, line, or polygon. So it's like a rough approximation of real-world landscape. But again, nowadays I think a lot of GIS systems are moving well beyond vector-based systems. For example, Google Maps, has all those satellite images that can be viewed not as vector-based GIS, but more like photo-based GIS. And then there are coverage models that basically allow different logical representation, for different users, that would look something like that. So there's a photographic or satellite representation, there's a customer representation, there's a sales representation, and one layer can be added on the top of the other layer. Now, geographic information systems, they haven't been subject to hype. I think they've been gradually developing over the years. There are a lot of interesting applications of GIS. In fact, one of the first articles that I published with the doctoral student of mine, Nader, was actually about GSS, but not GIS technology per se, but more about implementing GIS within an organization. Now, my co-author, Nader, he's actually a GIS manager for the government, for the municipality of the Emirate of Abu Dhabi. More specifically, he is his division is responsible for issuing permits related to sewage. So, for example, if you're building a new house, or you're expanding your house, or you're building a new restaurant or something like that, naturally you need to connect to the sewage system. And this is where they come in, because they will look at your plot and they will give you a permit or recommendation where where and how you can connect to the sewage line, if at all, right? Now they bought their system from one of the vendors, from one of the vendors, and they populated that system with their own map data and with their own records about plots and where various sewage pipes are located. Now, what Nader says is that one of the biggest problem with GIS is not the technology itself. I mean, they did have a lot of technical problems related to the speed, of the system, how quickly data can be entered and retrieved. Eventually, all of those issues were solved. In fact, the system is quite, on that operational level, is quite useful, because now they're professionals, they're engineers, they can look at the map and issue permits much, much faster. But one of the biggest problems they're facing is more like on the organizational and human side. The fact that not everybody is using GIS system for whatever reasons, right? Some people, they don't use those GIS systems because they are scared of the technology. They don't have enough competence to use it. And yet they will make some kind of case, a solid argument that somehow system is not useful in their work. Others will just do it to save time or to address some kind of unique custom situation that cannot be readily addressed using standard operating procedures. Now, if that happens, it's a big problem, because you don't want to be in a situation where you have like an additional sewage line and that line is not entered properly in the geographical information system, because somebody else will get a permit to build something, to, I don't know, install, dig ground or build a foundation in that place, and they will cut into the sewage line, and the pipe will put all the sewage waste on the ground, and in fact it happened many times, and the reason I knew it happened because of the smell. There was like my university was near that construction site where there was just like a vast area outside of the city of Abu Dhabi, where there was so much construction going on, involving different builders. They were basically building like a whole city, not just like one neighborhood, just like a whole city. And once in a while, I could, because I had to drive past it, I feel that smell, and that's when Nader would typically say, "Oh, I'm so busy at work, I cannot come, I cannot do this," because he had to deal with those accidents, involving sewage lines. But that typically happens when somebody is not properly, constructing, or not, where the permit has not been properly issued, or somebody ignored that requirement of having a permit before doing anything. So that's the main problem. It's more like on the human side, operational side, and not on the technology side. So yeah, I mean, nowadays organizations can buy a lot of off-the-shelf solutions for GIS systems. But of course, you may want to include other data sources. Your GIS needs to be customized for your own specific needs. So for that, you need to retrieve a lot of data. And again, to tell you a little bit about my research project on GIS, we found out that basically Basically, for them, data transfer was a huge issue because a lot of the permits that they had in the past were basically like huge stack of papers, like one big folder with papers. So somehow all the data had to be transferred to the GIS system. So this particular organization, the municipality of Abu Dhabi, they ended up hiring like a specialized data entry company to enter all this data because they just couldn't handle it with their own resources. Yeah, so there are a lot of GIS vendors nowadays for various applications, but again, typically off-the-shelf solutions that need to be customized. Okay, friends, so that concludes part 1 of our video presentation on Chapter 6 that deals with managerial support systems. Thank you for listening.